Mr. Vinit Priyadarshi. He is presently servicing as Account Manager of Operating Asset Solutions Portfolio with Black Veatch India. He has around 22 years of industrial experience in conventional and renewable power generation assets. He holds a degree in mechanical engineering and has received a master's in business management from Indian Institute of Management, Calcutta. He is also a certified energy risk professional from Global Association of Risk Professionals from USA and an accredited energy auditor from Bureau of Energy Efficiency in India. Today, Mr. Vinit will give his submission on the plant performance optimization using advanced digital technology, a futuristic perspective. I would like to invite Mr. Vinit Priyadarshi.
Thank you, Mr. Nitish. Talked about certain aspects which are quite concerning for a developer's standpoint, mainly the power plant economics of running and being competitive in this market. And then he also talked about the concept of sustainability. Mr. Bharat Sharma talked about certain aspects of the demand and the supply and how increasingly we are seeing lowering of the demand, especially when we talk about in the balance of the PLF, though the overall demand of course is going up like anything. I think the speaker just before me has talked about certain aspects of digital transformation for the power industry as such, and he has given a very rich perspective about certain elements which probably I will also touch upon in this presentation. So I'll just talk in a very brief certain philosophies, approaches, which as an organization, Black Veatch has implemented across the power plant fleet. And then we have achieved tremendous success in terms of cost saving, in terms of achieving the sustainability or emission compliance and so on and so forth. So certain ideas I would just like to share for the benefit of the audience here. A quick view of the agenda, and so I'll speak quickly about Black Veatch as an organization, then talk about operating assets, solutions. We have a vast portfolio of solutions. Then we'll cherry pick few of those solutions for the audience today. I hope those topics are definitely be beneficial to everyone here. We will just talk about few proof cases and then lastly we'll take up the panel discussions. So Black Veatch globally is headquartered in US and we have around 8,300 professionals in more than 120 offices. We are EPC firm, so we do large scale PC work both in coal plants, gas plants and oil and gas, and other infrastructure facilities like telecom. At any point of time, we have more than 7,000 projects from various offices. In India, we have 2 offices, one in Mumbai and another in... And then we have been existing in this business for almost 107 years. When it comes to this operating asset solution, there are a variety of challenges we see across the globe. Every region, every country is unique in terms of its challenge. Like talking very specifically about India, we are seeing significant pressure, especially at the governmental level, for decarbonization of assets. And here, the coal is essentially bearing the worst impact because they are seen to be highly polluting. And then, there are a lot of emphasis on renewable integration. So we have some solutions around this particular problem statement, and we have been supporting utilities here in the country to decarbonize their assets more sustainably, more efficiently. So today I'll talk about 2 of these solutions, coal to gas switch and coal and biomass co-firing. Other than that, other challenges when you talk about Indian perspective is I think Mr. Bharat Sharma touched upon renewable integration and essentially the load flexibility, which is more or less becoming a commonplace theme for almost all large-scale coal-based power plants. In India, if you look at the composition, we have supercritical and subcritical boilers, and then you have varied sizes ranging from say 210 megawatts to something like 800 megawatts. Now, every plant has its own operational constraints, but the fact of the matter here is that you have the renewable power which is available intraday and it's available at a competitive cost. So given this fact, you require somewhat more advanced digital solution which would help you do this load flexing more economically sustainable way. And at the same time, you have your other compliances too, like environmental compliances, so many other things to look after. So I'll talk about another solution that we have, which is asset performance management, and we have our own proprietary tool called Asset 360. So, starting with Asset 360, it's basically a concept in general, but the idea here is that use machine learning to basically predict any failure in advance. Now, the lead time of this prediction may vary depending upon the complexity of the problem. But in general, all machine learning tools, they let me just share my pointer. All machine learning tools, basically focuses upon the predictive assessment of any problem using real-time data from sensors, and normally they are aggregated at certain stage in the network, and then they pass through some filtrations, and eventually they go into the machine learning part of the algorithm, where you try to analyze the pattern and see what are the steady state condition, what are the unsteady state condition, and then you work out what should be the right action. So essentially it starts with building predictive models, then you tend to detect the problems very early. That is the core of the solution. And I think every solution utilizes its own approach, but typically a power plant problem in our view can be predicted in as advanced stage as, say, a month prior to its actual occurrence. So sometimes, depending upon the severity and the complexity, it might just be detected very, very close to its failure. But it will give you some lead time to plan and then to prioritize and rectify the problem. So this is the third sector here in this circle. And finally, you need a workflow mechanism wherein there is an exchange of information between multiple parties. Whosoever is expected to resolve the problem at the field, and whosoever is expected to provide the expert assessment of the problem. And this needs to be very seamless in nature. And eventually this will lead to resolution of the problem. So this type of concept has been utilized by various OEMs. Black Veatch is a third-party service provider, so we are OEM agnostic, but we have this tool which have been deployed across a variety of asset fleets, and we have utilized it for all the OEMs, sometimes for the benefits of them or sometimes for the benefit of the whole. So the concept, just to re-emphasize here more diagrammatically, you need to learn the pattern in the data. You need to figure out what is normal, what is abnormal. You need to bring the sensitivity in the model so that you can detect the problem very early. So this is essentially art in the modeling part of it. And eventually you have to define what is it going to impact. Like you have specific KPIs like your availability factor, your heat rate, boiler efficiency, box power consumption, so you need to figure out which part of the performance this particular problem is really linked to and how it is going to impact it. So the concept is all in terms of early identification of the problem, and then understanding the nature of the problem, figuring out immediate action plan required for outage, figuring out long-term remedial actions, and then in the process you look out for overall optimization. Some of these concepts would be clear when I'll present the proof cases. As far as Black Veatch is concerned, we have got 5 monitoring and diagnostic centers where we are getting almost 1 million of equipment data from variety of assets. Power plant is one, but other than that, we also get a lot of industrial assets data. And then we have M&D experts, we have subject matter experts in different areas given our EPC presence in this space. So you see, this is the sort of a portfolio which we cater at present. Coal plant worth 65 plus gigawatt we are monitoring at present across the globe. Gas plant 14.6 gigawatt. We are also monitoring renewable assets, water and wastewater assets, so small IC engines, microgrids, floating LNGs, pulp and paper, petrochemical complexes, fertilizer units. So the concepts of machine learning, AI-based predictive analytics remain same, and it's quite universal in its applicability. The problems are also universal, for all of these industries. They are all striving to generate their end product at the least cost. They're all striving to achieve carbon neutrality target. They're all looking for a sustainable way to preserve the O&M knowledge that they have so far harnessed over the years. And the answer to each one of these problems is inherent in this type of solution, like Asset 360. This is another problem which I would like to discuss, and more so in the parlance of India. I think most of you might have heard about the notification from Central Electricity Authority, I think in probably October, November timeframe last year, where coal plants specifically have been asked to utilize biomass as a co-firing fuel. And ministry has also categorized about the type of biomass which they need to use, essentially agro-residue. The problem, of course, was essentially the smog formation in the NCR region, but you see the impact was overall spread to the whole country, including all the coal plants who are now mandated to co-fire biomass. So Black Veatch has collaborated with EPRI some way back in 1985, wherein something similar of a problem we faced in US, where because of the Clean Air Act and then mercury and toxic chemical acts, many coal plants were asked either to shut down or else to decarbonize themselves. So essentially in US it all started with decarbonization in terms of a fuel switch from coal to gas, or a coal and gas co-firing. Eventually, given the biomass market availability in Europe and then some big players in US, many coal plant or fleet owners have also switched over to biomass. So nowadays, in case of US, if you will see, almost most of the coal plants have got this dual fuel flexibility, and then most of these plants are actually being subjected to intraday cycling. Sometimes they also undergo stop operation. Now, amidst all these problems, we did a lot of research and then we figured out this particular digital boiler modeling solution in collaboration with EPR. We call it Vista. This is one of the most comprehensive tools globally. I think probably no other tool is really so vast and so in-depth in terms of its assessment of boiler problems than Vista. We have utilized this tool in more than 1,000 boilers actually, and then it's essentially a not-for-profit organization which is promoting this tool and its continual development. This tool basically addresses the problem like biomass co-firing, coal to gas conversion very directly. It captures all aspects of this type of problem, whether there is an issue with respect to the steaming rate of the boiler, whether there is a problem associated with maintenance and availability, like slagging, fouling, corrosion, erosion, boiler tube leakages, propensities. If there are any equipment retrofit needed, say sizing of a fan or sizing of an air heater, this tool can give you the answer directly. All type of boiler modifications are part of it. If there are combustion optimization requirement, the tool can be utilized to do this. It's a first principle based thermodynamic model. As I said, it's very granular in its nature and it's very fundamental. So it solves the problem at a very fundamental scale. Black Veatch is using this tool very extensively for all its EPC works and various retrofit modernization works globally, including supporting OEMs also using this tool. And in India, we have recently started utilizing this tool for some of our clients who are actually being challenged to switch to biomass, and then we have been recently using this tool to support them in their entire program management efforts for biomass switch. Just taking a few case studies here, and that will give you some understanding of what type of problems a utility owner may face. So we talk about heat rate, and then reheater is a critical element into it, because reheater sprays is one of the most expensive mechanism to control the steam temperature, and it has a significant penalty on heat rate. So normally, all the operators are well tuned and well equipped and knowledgeable to know that reheater spray is not allowed. But seldom we see that because of some negligence, like in this case, after a soup blower operation, an operator has failed to note that the reheater spray is still ongoing. But the beauty of this type of, like you see this graph here, which is appearing, the red color suggests the expected value after the soup blowing, and then the actual spray that has shooted up like anything. So this is a machine learning model of the reheater spray system. Normally, if someone would look at it, they may see it as an occasional occurrence, but here in this case, this problem lasted for almost, and the spray was not very high, but still, the penalty is high given it's a reheated spray. It's bypassing all the heaters altogether in the cycle, in the Rankine cycle. So this problem, if it's being detected very quickly and early, you may take a calculated action, and then you may get this one sorted out, just like here in this case. The problem was identified very early, and the spray just shooted up, but it was analyzed that is this reheater spray really be needed given the situation after the soup going, with the steam temperature going up, and then in a controlled and articulated way, the spray was stopped. Actions by the operators. A similar problem I would like to highlight here is with condenser fouling. This is one of the most commonplace problems almost found in all coal plants, and this is progressive degradation, and this is very hard to detect sometimes. Like in this case, there was an observation that the vacuum has gone up deteriorated very slightly, like here in this case 1 inch of mercury content. Now in a solution which is slightly more advanced, you basically not just capture the raw sensor, but you also see the intermediate KPIs, which actually reflects certain aspects of the root cause of the problem. So like one such indicator here is cleanliness. So you see the cleanliness number going down, and the degradation here is gradual. You see some changes in CW discharge. Many a times, it becomes very difficult for an operator to really figure out what's the correlation of these parameters. So there are certain tools in the market which actually provide this correlations amongst the varied parameters that have been impacted because of a certain problem in the system, and then they help us know what should be the right action. Like in this case, this operator, after observing this issue, was more interested to look at the historical behavior of the problem. So you see there are 3 lines here: green colored lines, blue colored lines, and red colored lines, and he's seeing that over a period of say around 1.5 years, there is a progressive degradation in the condenser cleanliness, or here in this case it's a vacuum load, and he has actually sorted it out for a given load. So this was a long-term problem, but in this case, given the issue of rise in condenser vacuum, what was eventually figured out later on was that a dosing system for chlorine was not properly operated. So the chlorine concentration in water was not taken care of, and normally there is no sensor actually to detect all this. It's all being measured offline. But the problem, as you see, vacuum has deteriorated, and the dosing valve was not properly operated, and then it was all leading to a condenser vacuum drop, and eventually a loss of cleanliness too. So the point here is, if you know the problem very early, this loss can be avoided before it goes to very high range, and then you can take the appropriate action. So this is the last slide, but I just want to highlight here certain aspects of the presentation today. That we are the one who provide the full service in terms of power plant optimization, and then we do a lot of EPC work, so we know the in and out of all the technologies. And we have an O&M team here that takes care of any problems in the power plant performance. We did a lot of modifications in the system, whether it is a VFD retrofit or any type of pump coating or whatever efficiency measures are needed. We typically do that type of work, and we welcome the opportunity and privilege to serve you as you explore to decarbonize your assets. That's all. Thank you very much.
Thank you, Mr. Vinit, for such an informative submission.